All right. We'll kick off. Thank you all for coming along today. My name's Jonathan Giles. I flew here all the way from, wow, I can't see you all anymore. I flew all the way here from New Zealand to present to you today. I work for Microsoft. I'm a senior cloud developer advocate, and I want to talk to you today about Java API design best practices. If you've got any concerns, questions, feedback, feel free to email me. That's my email address, jonathan.giles@microsoft.com, and I hope to see you all following me on Twitter @JonathanGiles. Today's talk is about Java API design as it relates to jar files that you might download from Maven Central or public classes that you might write with public methods. I'm not talking about RESTful web services and that kind of API design. So if that's what you're expecting, I apologize now. I'm curious, and I can't really see hands anymore, but I'd love to know how many people are using JDK 10. If I could see a show of hands. Only a few. What about JDK 9? Again, only a few. JDK 8 is what I expected to see. Pretty much a room full of people with JDK 8. Anyone still on 7? 1 or 2. Anyone suffering on 6 or below? Okay, that's good. So I guess to introduce myself a little bit further, my name's Jonathan. I used to work at Sun and Oracle. I was actually at Sun in 2009, and then we pretty much immediately got gobbled up by Oracle, where I was until the end of last year. And my job at Sun and then Oracle was to work in the JDK team on the JavaFX UI control specifically, but I was really caring about anything to do with JavaFX. So I don't know how many people are familiar with JavaFX, but it's a UI toolkit that was developed by Sun and Oracle. And late last year, I moved over to Microsoft, and I made the transition at the same time from being an engineer to being a cloud developer advocate, which basically means I write less code, I complain more to engineering internally, and I come out to talk to people like yourselves about things. So I feel like I'm qualified to talk about Java, even though I'm from Microsoft. I feel like I've got the history there to at least qualify me partially. And throughout all my work on JavaFX, what I realized I really love doing is developer experience. I love solving problems that make developers more productive. That starts with API, but it extends to documentation, and anything that's going to create friction in what the developer has to do to get their job done. That's what I care about, and that's what we're going to be talking about today. How can we improve developer experience? And we're going to split the talk up into two halves. We're going to talk about API design theory, and then we're going to have some practical advice. So let's start with the API design theory. And I found this image drawn by one of my colleagues, and I thought it was an apt metaphor for what we do as API designers. We start off with a sandbox that's completely flat, and we're the person that turns up to it. If you're not keen on playing in sandboxes, think of yourself as a dungeon master in your D&D. You're someone who's in control of the world in which other people come and interact with. And you can make this a really enjoyable, productive, positive experience for the users of your API, or you can make something hellishly difficult to use. It's really up to you. So as API designers, we want to be the ones in charge of this sandbox or the dungeon or whatever the case may be, and we want to make something really productive and enjoyable for the developers. So an API is obviously what some developer uses to achieve some task. And of course, we could exist in a world entirely without APIs. We could just write everything starting straight from Java, and we could write our own HTTP library, collections library, reactive library. We could do it all internally ourselves. But that's not a very good approach. An API is abstract implementation. They allow us to work at a higher level over raw Java. And so when we design APIs, we have two key questions. Who is the user of the API, and what are their goals? For example, let's take the date-time API that came out in Java 8. We could have an API that just deals with the milliseconds since the epoch, or we could have something that's incredibly complex with all different calendar types that exist. But the users of the date-time API in Java are people like you and I. We're programmers. We don't care necessarily about all the technicalities of time zones and how the different Gregorian calendars and everything work. We just want to know if a date is before or after another date, for example. So we have to target the right audience. And I've got another question for you guys. How many of you are API designers? Okay, I'm seeing about 5-10%. That's good. The actual answer is we're all API designers, right? We're all people that write public API in the sense of public classes with public methods. Anyone that writes public classes and public methods should consider themselves an API designer. And so the goal of today's talk isn't to, it's not, what we want to do is we all want to have higher standards of API design. So that's what we're going to get through for the rest of this talk. And so the characteristics of what an API has, in my opinion, and I like to say this a lot throughout my talk, this is my opinion. I encourage you all to disagree with me. It's okay. We're all entitled to our opinion. They're like noses, right? An API has to be understandable. Obviously, how many people have gone to Maven Central, they've downloaded a jar file, and they've wondered how the hell they actually use this jar file? Where's the class that they start with? And if they find the class that they need to start with, how do you instantiate that class? Is there an obvious constructor? And if not, what are all these arguments that go into this constructor? How do I actually get started with my code? And part of being understandable is also being well documented. So obviously, I'm a huge fan of Java.doc. Everything I document goes into Java.doc, and I'm going to talk about that shortly. Another thing I'll talk about shortly is consistency. It's really important that internally we all have consistent standards inside our organizations, whether it's for our own projects that we're just working on our own, or whether it's in our open source project or in our organization, and whether we're shipping the API publicly or whether we're just using it internally. The next thing is it has to be fit for purpose. Going back to what I said before about who is the user, we have to make sure that we're actually designing the API that the user wants to use. Probably the more controversial of the topics that I want to talk about is being restrained. You won't believe how much hate mail I got as a JavaFX API designer on being restrained. And that means having a minimal API, having an API that has lots of finals in it. You won't believe how many people hate the final keyword, but really as an API designer, it's one of your best friends. And finally, being evolvable. And that kind of goes hand in hand with being restrained. If we're restrained, but we know how we're going to evolve our API over time, we can have a better API in the long run. But if we rush to have everything in the first release, we're kind of backing ourselves into a corner. So the goal is to be restrained, but know how we might evolve as time goes on for subsequent releases. I'm going to go on about this a number of times. I apologize in advance. I'm going to say API is a contract over and over and over, because that's the best way to think of an API. It's a bond that you form with your users. Once they start using your API, if you change it, they're going to be angry users. Whether it's just yourself, you have to go and change your code that you've just previously written, or whether it's your customers or inside your organization. Adding new API is mildly acceptable. Of course, there's always a chance of collision, but removing or modifying existing API should be done only in a very considered way. So I like to talk about the journey to 1.0.0. That's when we kind of say, we're locking down our API now. We're not going to make significant changes to it any longer. And API design is incredibly cheap. You know, anyone can bring up IntelliJ or VS Code if I'm talking for Microsoft, and public class something, public methods, and all of a sudden you've got an API. Was that the right API? Maybe, maybe not. But we can iterate incredibly cheaply. However, once we release our API to the public or to our users, it becomes incredibly expensive to change our API. All of a sudden, we've committed to something that other people are now using. So I like to say there's a journey to 1.0.0 where you should get more and more feedback and more stringent reviews on your API before you release. And we should justify everything. I've trained a lot of API designers over the years, and I was once trained as an API designer. And the question that I ask everyone that I work with when I'm reviewing APIs is, why do we need this? And it's not to be a dick. It's not to kind of challenge someone and show authority. It's everything needs to be justified. Everything should be given a reason for its existence. And as API designers, it's very easy to say, I'm going to add some more API. I'm going to add some convenience API. And it's going to cut down 5 lines of code for some developer to have to write later. Every time we make that commitment to making the developer's life easier, we might be making our lives harder. We're backing ourselves into a corner a little bit more each time. So for a first release, at least, we should really understand what the core offering of our API is. And we should force ourselves to justify every piece of that API so that we only have the minimal set. And we can understand what the user's feedback is from there, and we can evolve over multiple releases. When a developer first starts to dive into an API, they don't just dive into the whole of your API. For example, JavaFX had dozens of API, all the different UI controls, the scene graph, accessibility, CSS, a huge amount. But you're not going to dive into the whole thing and just understand it all at once. You're going to start with a small piece and move on to other parts of the API as they become relevant to your needs. So consistency is incredibly important. If we can ensure that our API is consistent across our offering, and it's things like return types, method naming patterns, argument order, and consistent instantiation process, we can ensure that when developers first land on a new piece of API that they haven't seen before, they can kind of intuitively understand how to proceed with the API. So I'm going to talk about all of these later on, but return types, it's terrible when you see an API that has every single kind of collection return type, list, collection, iterator, iterable, stream, see it, whatever. It's good to kind of choose. I'm going to say this a few times as well. Pick your horses in your race and bet on them. Don't bet on the whole race, right? But you wouldn't believe how much we agonize inside Sun and Oracle over just method names. What's the right name for this particular method? Don't be an idiot that overloads your method 5 times and has different argument orders for each of them. That's just asking to be punished, right? And have consistent instantiation order. Are we using dependency injection? Are we using constructors? Do we use builders, for example? Let's try to be consistent in our API. What all this leads to, though, is having developer empathy. We want to feel what the developer's feeling when using our APIs. And the best way to do that is actually to be the first customers of our API, writing sample code. We had, at Sun and Oracle, we had dozens and dozens of test applications for every single part of our API that we would just bring up on a weekly basis just to kind of gauge how we feel about it this week. And we want to review for unclear intentions. Is the code not clear on how it's to be used? Does it result in duplicate or redundant code from being written? And is the abstraction too high or too low? That goes back to the date time example. And ultimately, a good API comes from good practice. And I was lucky to have a mentor, and I encourage anyone that wants to get better at API design just to find someone. All they have to say is, why do you need this? For every single public method, every single class, why do you need this? Because so often, actually, you don't need it. I'm a huge fan of documentation. I've got open source projects, and I always specify in my open source projects, controls effects for JavaFX, for example, that the documentation has to be of the highest standard. We should do things that include code snippets in there, and we should make use of the common annotations, things like @c, @since, @link, because this builds a richer documentation experience for our users. They can all of a sudden start moving around the Java doc. And I'm going to bang on about Java doc a lot in this part of the presentation because I think it's really important. And so this is some documentation I wrote recently for the Azure Functions API. It's the HTTP trigger Java doc. And the point that I want to make is you can see there's a code snippet in the middle. It's not 50 lines of code on how to use it. This is an annotation. This is how you apply the annotation to your code. And then it's got descriptions on the most important aspects. So this is what I want to see when I see Java doc. What I don't want to see, and I've learned this through painful experience, is what I call negative examples. And a negative example is when you say, don't do this. I realize nowadays that we live in a Stack Overflow era where basically people go to the first most highly rated response, they copy-paste the code into their IDE, and they move on with their job. I didn't realize this back when I wrote my Java doc for JavaFX, a much earlier release. I would write examples that say, don't do this. This is bad. Here's a better way to do it. Users don't read any of that. What they read is, oh, there's a piece of code, I'll copy and paste it. And then for a very long time afterwards, I would get bug reports coming into the Java bug system saying, you're an idiot, you wrote bad code, why doesn't it work? And so here's an example. I went through a very old release of JavaFX. I couldn't find the best examples, but this one's a decent one. It starts off with a bold warning saying, a warning about inserting nodes into the combo box items list. Then it goes, this is strongly not recommended. For example, rather than use the following code, you should do the following. And do you know how many bug reports I would have got for that first block of code? It was dozens. And all I could really do was point people to this document and then close the bug. But the point is, don't have negative code examples. It's not worth the pain. Only focus on the positive. Just show people how to get things done. Don't show them how not to do things, because people don't read the documentation as much as you'd like. The other nice thing about Java doc is it's a really, really good way to review API. Whenever someone asks me to come in and review their API, I clone it from the repo, and I run Maven Java doc or Gradle docs or whatever the task might be to generate the Java doc on my local machine. What that enables you to do is look for things that don't feel right. So is there a class that shouldn't be there? Is it missing Java documentation, or is it incorrect? For example, I always go into the habit in JavaFX of having sections in my code. So I'd have a Java comment basically that says this is the constructors section. And if I forgot to write a constructor comment for the first constructor, the Java documentation for that constructor would be constructor section. So you can really easily identify that kind of thing. And of course, the other thing to look for is unintentional API. So things that are actually implementation, either it's methods that should be private or hidden somehow, or it's whole classes that should be private. And so this all leads to having a team consensus. What we want is our team of engineers inside our organization to have a team-wide cheat sheet. We all want to be on the same page, right? We want to have something that we can share with all our new hires. We want to have something that ensures consistency. All of our engineers are doing the same thing, because if 9 out of 10 of your engineers are doing it the right way and one's doing it the wrong way, when people come to use your API, they're not going to trust that your API is always going to do the same and the right thing. And what we want is to have team members a way to give feedback. So, for example, you might use Microsoft OneNote. Sorry. Our goal is getting everyone moving in the same direction, right? We want everyone going in the same way so that we end up with a consistent, high-quality API. Just as a slight digression, I want to talk about generated APIs. And these APIs, for example, where you're kind of serving two masters, right? You've got, for example, in Azure and at Microsoft, we have a bunch of Azure web services, obviously. And these are specified by the service teams as Swagger files. And the other master is the consumer of the web service via the Java APIs. And so we're stuck in the middle here, where we have to have an API that is serving two masters. We have to make sure that we're representative of the Swagger specification, but we also have to have an API that's usable by developers in Java, for example. So the way we do this at Microsoft is we have what we call the auto-rest tool. It's free, open source, and what it basically does is it takes a Swagger specification and it spits out a Java API and Java implementation. And does that not just for Java, but it does it for Go and Ruby and Python and C# and all the different languages. On the one hand, this is perfect because the Swagger spec changes all the time. It's something that the service team's in control of when they add new features to their services. They put it in their Swagger specification, and it's up to the SDK team then to generate the SDK. On the other hand, this is really terrible from an API design perspective because it's robotically generated API. It's not very friendly. And you look at it and you go, this is not the artisanal API that we want to be designing, right? If you need to generate APIs like this, and it's fair enough, because imagine the burden of a company Microsoft size or much smaller that has to generate APIs for their web services in multiple languages. If you have to do this, evaluate your tooling options. There's dozens of tools like this out here. Auto-rest is one of them. Generate Javadoc. Javadoc is going to show you how it feels. What we do at Microsoft is we have a convenience layer on top of this automatically generated API. And this convenience layer is basically a Fluent builder interface. It's much more well-designed from an API perspective. And it just calls through into the auto-generated API. This kind of gives you the best of both worlds, right? If you want to be on the bleeding edge and use the latest functionality in the web service, you can use the auto-generated API. It's not a terrible API, by the way. It's just not as well-designed as you would like if you were doing it yourself. If you're happy to kind of lag a little bit, because there is obviously a lag time whenever you have changes in the auto-generated API to reflect them in the convenience API, then you can use the convenience API for a far nicer experience. And what we do is we basically put out both jars onto Maven Central, and you can opt into one or the other. So there is no magical process to API design. Automatic generation isn't going to get you there, and it's one of those things that's kind of like an art. And I really enjoyed API design when I was doing it at Sun and Oracle because it exercises a different part of your brain, right? I'm used to writing a whole bunch of implementation code, but every now and then I get to pop up and write API, and it's kind of, you're using the other side of your brain. So it becomes easier with practice and obviously having a good mentor. So that's kind of the academic side of things. What I wanted to do is spend most of my time on the practical advice. How many people have read this book, Effective Java? About 40% of the room. Highly recommend it. How many of those people that have read it have read the 3rd edition that came out late last year? Yeah, that's about 5. I highly recommend everyone, email your manager today, ask him to expense this book for you. It's a really, really good book for Java developers, right? It's got 90 tips in it in the latest version, and it's been upgraded for Java 9. So the last edition, the second edition, came out 10 years ago or so. It doesn't include things about like streams and functional interfaces, and this last version is well worth the time to read. In the advice I'm going to give, in some sections, I'll go to the next slide to show you. Up the top right, you can see effective Java item number 1. So if you want to learn more about static factories, you can go into the book to learn a whole heap more. So let's just dive in. I've got 10 or so tips that I want to work through. First one, static factories. Static factories are really good for 3 reasons compared to constructors. First of all, they can be named. Obviously, a constructor has to be named after the class that it belongs to. They also allow you to return a cached instance. You don't have to return a new instance like a constructor does. And finally, you can return subclasses, unlike a constructor, obviously, that returns an instance of that class. And we've been using static factories all along, right? Everyone's probably familiar with methods like this, static Boolean value of. It takes a primitive Boolean, and it returns a cached value of either Boolean true or Boolean false. And now you can imagine if you had a for loop that was doing 100 million iterations, and it was calling new Boolean each time, you'd end up with 100 million Boolean objects if you called new Boolean. If you use Boolean.value of, you're actually not creating any because you're just using the 2 that have been cached previously. That's the benefit of static factories. You don't have to return a new instance every single time. And of course, value of is a fairly more readable name than new Boolean. And they're always getting added. There's a whole bunch of them getting added all the time. In the list, there's a whole bunch added, list.of. And you can see there's actually 12 overloaded versions of this method. It's list.of with no arguments, with 1 argument, 2 arguments, all the way down. And finally, there's an varargs approach. This returns an immutable list, and if you think about how you would do this in previous versions of Java, you'd have like list, mylist equals new array list, list.add, 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 right? This allows you to do it in a far more succinct, short way. Now, as an API designer, you might look at it and go, well, actually, I don't like this. Why do we have to have 12 overload versions? When you go to list.of, it's just going to confuse people. The argument for doing it this way is simply performance. And sometimes there's a trade-off between performance and API design quality. If you only have the varargs approach, which will obviously handle all of the cases above, you're going to have to pay the price of an array instantiation every single time you call that method, which actually could add up to quite a bit of performance cost, which is why there's the overloaded versions. You end up not having to pay the cost of the array if you call list.of with just 1 argument. And so it's one of those trade-offs, right? We can either choose to have purity of API, or we can consider it from a performance and API perspective. In this case, if you had asked me as an API designer if this was the right call, I would absolutely agree that it was. It's a bit noisier, but it doesn't really confuse the developer a great deal, and it gets rid of that performance implication. So let's just do a really, really simple example of a static factory. So let's have a random integer generator, and it generates a random integer between minimum and maximum, and it's got a next method. So every time the next method is called, we're going to get a random integer, and we're going to, first of all, do it with constructors. So we're going to have a constructor that takes the min and the max. Fair enough. We're going to have another random int generator that takes just the min, and it goes all the way up to the max value. And we're going to have a final random int generator that takes the max. Now, if anyone's paying attention, obviously that's not going to compile. You're going to have a duplicate error, duplicate method error, simply because from a Java perspective, we've now got 2 constructors that both take integers, and it's not clear which one is to be called. So this is not going to fly. So let's just quickly redo that with static factories. Let's add a private constructor. So at this point, this class can't be instantiated. It's a public class with a private constructor. You can't create this class. And we're going to add some static factories. First of all, we're going to add a between method, making use of the static factory's ability to be named rather than just having the constructor, the class name. And we call it between with a min and a max. Then we can say bigger than min and smaller than max. This is something trivial, but I wanted to make the point that static factories have a lot of value. And the other point I want to make is it's contentious. Everything I'm going to say, you can agree or disagree with. I don't mind. I did a quick search on this specific topic, and I found someone arguing static factories are the devil, right? They're the worst thing ever. So as with all advice, form your own opinions. Don't take my word as gospel. And the main thing is what we want to aim for is consistency within our own organization or in our own project. And that really then informs our developer empathy, our API quality, and our desire for high design standards. See, public API is a contract. I'm going to keep saying this. It's really easy to think that I want to add more API. More API, it must be right because I'm an API designer. If I'm paid by API, then that must be the right thing to do, right? But there's two concerns. Obviously, we have the developer overload problem. And that kind of goes back to what I was saying about the list of situation. If we add and add and add, we're actually just adding to the burden of the developer who's using our API. All of a sudden, they have to spend more time going through our Java doc or the IntelliSense that pops up in their IDE to understand how to use the API. But more important for us as developers of a public API is that we have a greater maintenance burden. And it may seem strange, this concept of maintenance burden. It's just public API. We can change it whenever we want. But we want to try to not change things. We want to try to lock things in and make developers' lives easier. Every time we change API, we make the developer have to do something to handle it, right? And so we should start with private classes and private modifiers, and we should really make use of the private keyword. Now, in my experience, changing from private to public is never the right way to go. Normally, there's an in-between step that actually massages some private detail into public API. But we should not just by default make our members public in the classes. And fields should really be public. Of course, we're talking OO here. We shouldn't be having public fields as much as possible. And so the other thing about minimizing our API is that we should understand and properly manage our implementation classes. When I did this presentation last week, I spoke specifically about having an impl package. So if you're familiar with how we did things at Sun and Oracle, we would have a com.sun package, and that was where all of our implementation existed. And I encourage everyone to do that. Have a clear separation in packages between your API and your implementation. But there's another approach that someone gave me after I gave this presentation last week, and that was just make more use of package private classes. Package private is basically a class that's only visible to other classes in the same package. It works really well. We did that a lot at Oracle as well. Using the impl approach with an impl package actually works really nicely when it comes to things like documentation and JDK9 modules. So with documentation, all of a sudden, you can just exclude that from your Java doc build. So the impl packages just aren't part of your public API. And if you choose to move to JDK9, all of a sudden, if you start to use modules, you just don't export the impl package. So you only export your public API packages, and the implementation is no longer visible. Now, as the person that was heavily involved with JDK9, I can appreciate how painful it is to move to JDK9 because we removed all of our implementation. But that was kind of a painful exercise because everyone uses implementation details because they need to do it for some reasons. And so the next tip is intentional inheritance. By default, and this is something that I got a lot of flack for, is you should try to make as much of your API final. That means you take back a little bit of control. You're not taking back all of the control, but you're saying that your classes can't be subclassed and your methods can't be overridden if you make them final. This means that you are now a little bit more in control of your API. You can't make changes because people are depending on it, but you can allow it to evolve in a more considered fashion. Protected API is one of those weird parts of the Java language. In my experience, every time you add protected API, you're in the middle ground, right? You're in between public and private, and it was very hard to do protected API right because almost inevitably, whenever you add a protected method to a class, you realize actually I need more functionality to be exposed, and it's a kind of a slippery slope till you end up with an entirely public class, which is not where you want to go to at all. So just whenever you have classes that have unprotected API, it's well worth the time just to actually consider writing some code that uses it to make sure that the intentions of making it protected are fleshed out. All right, your API is a contractor game. If you expose external dependencies, and what I mean by this, if you start relying on, say, OK HTTP or RxJava or any of those popular libraries, that's totally fine. You need these things to get your job done, right? But if you start exposing it as a return type or as an argument into a public method, that becomes part of your API surface area. All of a sudden, that is something that you are kind of responsible for as well. for example, let's just imagine Rx Java. We're returning that as an argument. Imagine that completely falls out of fashion. It's found to be completely faulty, it's flawed, and it doesn't work, right? But our API is now returning it. That obligates us to either replace it or work out a way to evolve away from it over a longer time period. And so we just have to, I'm not saying don't do it, but just consider it. And another option is to consider having some kind of wrapper. Can we wrap what we're returning with a class that abstracts away the actual implementation and has the person just use some class that you've created? That allows you to change it as things change. One other thing I've seen a lot of companies do is they say, well, I'm not going to solve the problem, well, I'm not going to choose which approach the developer is going to use. I'm going to choose all of the approaches. And then I'm going to have 24 methods in my class, and they're all going to return different implementation classes from different libraries, and the developer can just choose whichever one he wants to choose. That's a terrible way of doing things. It just complicates the life of the developer. What are they to choose? It doesn't inform them at all. And I'm a huge fan of just choosing one horse and betting on it and not trying to bet on the whole race, right? Tip number 5 is don't return null. If you can help it, don't return it. So, it's quite simple. If you're returning a string, consider returning an empty string. If you're returning a list, set, map, iterator, those kind of things, there's a collections class that lets you return an empty list, an empty set, for example. If you're returning stream, which is probably not highly recommended in most API design cases, just return stream.empty. An array, you can return an empty zero-length array. And for all other types, you can consider using optional. How many people have used optional? Oh, wow, that's pretty cool. That's most of the room. How many people have written an API that returns optional? That's about half. How many people have wondered if they did the right thing by returning optional? Yeah, that's what I thought. Optional is one of those funny things, right? So we're going to go on to that a bit. We're going to talk about optional. So for those that aren't familiar with optional, you can basically think of it as a collection that can contain 1 or 0 elements. It's basically Java's object-oriented way of never returning null, because instead you will always return an optional of either 1 element or no elements. It's best used in some cases. It's not perfect for all cases, but if you've got a case where a result might be returned, or it might fail, and you need to do something if it isn't returned, it's a really good use case. And it provides a huge number of convenience methods, some of which I've shown just here. So let's imagine a getFastest method. We pass in a list of cars, and we're going to get back an optional containing the fastest car. So the first line of code basically says, set the fastest car to be the fastest car. If our optional is empty, we're just going to have this invalid car that we've predefined. Perfectly good. It means that the fastest car variable is always going to be non-null. It's really good. If the operation inside the or else call is expensive, we can use the or else get method, which basically you pass in a supplier, a functional interface Lambda expression, that will do some expensive operation. In this case, I'm saying search the web. Fair enough, it's slow. We don't want to do that in all cases like the first line. If we want to throw an exception, we can just do that straight away. And we can do some really nice distinct stuff in that last line. We can get the fastest car. If there is one and it's not empty, just race that car straight away. We can just, that saves a lot of code, right? How many people have written optional code that basically looks like null checking in disguise? Because if you're writing this kind of code, you're probably using optional incorrectly, right? To me, this reads like an uglier version of a null check. So I guess when it comes to writing an API, it's good to actually understand how it's going to be used. And in cases when it's going to be used like this, personally, I would not bother having an optional return type. I would just return null, because you're basically in disguise saying this is exactly the same thing as a null check. And don't be the person that does this. I always joke about this. Have a return type of optional and return null. That's like the devil's work, right? The other thing is, if you have an optional, if you've got a method that's returning a collection of type T, for example, and from a few slides ago, don't return an optional of collection of type T, just return a collection of type T with an empty list. So optional isn't perfect for all cases. This is one of those cases as well. Slowly running out of time, so I'm going to speed up a bit. Beware of boxing. Boxing obviously is when Java converts between primitives and reference types, for example, int to integer and back again. And there's 3 main concerns when you use boxing in Java. For example, For one, there's the increased possibility of null pointer exceptions. Obviously, primitives can't be null, so there's no chance of null pointer exceptions. There's a question of correctness. The equality operator works differently for int and integer. And there's obviously the performance considerations. So correctness being the first point. Reference types are objects, so the equality operator compares object identity. So this may not be what's intended. So just let's quickly go through this code. We've got two primitive ints here. They're both 2. Obviously, the equality operator is going to return true, as you would expect. 2 equals 2. If we have two integer reference types, both values of 2, the first one, value2 dot equals value2 again, is true, as you would expect. But if you did value2 equality value2 again, it's going to be false. And if you're not fully cognizant of the fact that you're using boxing and you end up with integers rather than ints, this may be surprising to some people. You can end up with correctness problems. Obviously, there's a performance impact as well. And reference types cost more in memory than primitive types. So unless there is a reason to use reference types, it's probably better not to. Just use the primitive types by default. So here's a really quick code sample. I grabbed it from this article down the bottom here. And you can note in the second line of code that there's a long reference type. It's object rather than a primitive. And this operation is basically summing up a whole bunch of stuff, and there's a whole bunch of auto-boxing going on between primitive and reference types. This operation takes 6,756 milliseconds. If we replace that one capital L with a lowercase l, it goes down to 1,248 seconds for exactly the same operation. There's no reason why we had it. It was just kind of the way it was coded. It's 5 times slower for no benefit. So in summary, if you see a return type or an argument into your API that has a reference type, it should set off some alarm bells, right? It should smell a bit. In most cases, it's probably fine. But why do you need this? That's the question that we have to keep asking whenever we see API that doesn't feel right. Why do we need to have a reference type? Unless you can answer that, it's probably fine just to have a primitive type. This is a quote from the Oracle docs. It is not appropriate to use autoboxing and unboxing for scientific computing or other performance-sensitive numerical code. An integer is not a substitute for an int. Autoboxing and unboxing blur the distinction between primitive types and reference types, but they do not eliminate it. So, just be warned. Right. Tip number 8, become familiar with java.util.function package. I'm sure many of you, having said that you're using Java 8, have played around with Lambda expressions and streams and the like. Functional interfaces are the way in which Lambda expressions are enabled. If you're not familiar with a functional interface, it's an interface or an abstract class that has only one abstract method. So an interface with only one method, or an abstract class that only has one abstract method. It's really enticing when you first start playing around with things, thinking, I can write my own functional interfaces. Java has a whole bunch of them built in, right? There's 43 of them in the java.util.function package, and they're broken down into basically 6 categories. There's the unary operator, the binary operator, predicate, function, supplier, and consumer. And they all kind of serve different purposes. They have different arguments in and out. And so it's really important to get to know these 6 categories as well as all of them in that package. I won't dive into this because I'm running out of time, but this is an example of each of the operators being put to use in a particular use case. The unary operator, we're just using string to uppercase all the strings, and so on for all the other methods. I will be putting my slides online, by the way. If you just follow me on Jonathan Giles on Twitter, I will post all these so you can read through these at your own leisure. In some cases, the existing interfaces that are shipped in java.util.function, they do not suit our needs. Sometimes the name isn't descriptive enough. For example, you would never think of replacing the comparator interface that ships with Java, right? It's just a beautifully descriptive name for its function. And the other reason why you might want to have your own functional interface is if you wanted to add default methods into the interface such that more convenience can be attained by the end user. So if you do decide to write your own functional interfaces, Java has this concept of an @functional interface annotation. And this informs the developer, but more importantly, the compiler that is designed for Lambdas. And so the compiler is going to make sure that there's only a single abstract method in that class. And if there is more than one abstract method. For example, if one of your colleagues comes in and decides to add their own functionality into it and it makes it no longer a Lambda expression, and no longer able to be used as a Lambda expression, it's going to fail compilation. So, right, we're on to resources now. First of all, obviously, YouTube. There's a whole bunch of, this is a Josh Block. He's the guy that wrote the Effective Java book. There's a whole bunch of really cool talks by him and others on YouTube. I highly recommend seeking them out. SNCC is a really cool tool for looking at vulnerabilities in your API. So if you have dependencies, what SNCC does is it looks at your dependencies as part of your POM file, and it then does a scan on those dependencies based on their version and name, and tells you if you are vulnerable to any particular known vulnerabilities. Rev API is a really cool tool. It basically can compare two APIs. So if you've got an API from your last release and your new release, it will tell you if any of your particular API has changed in a way that you're not expecting. So I wrote tooling inside Microsoft that does exactly this. It looks at different releases and it will tell you if a breaking change has happened, and it will point you to it, and it will just make sure that you're cognizant of the fact that something has changed. It may be a considered change, but it may also be an accidental change. So just as a brief call to action, java.ms, that's our website that goes for all the Azure documentation. I highly recommend, if you're a Java developer, to check it out. There's a huge amount of tutorials on how to use all the Azure web services. The other thing is there's a massive free tier at Azure. There's just a whole bunch of free stuff. And it's not like you get credit, it's like unlimited free stuff for the rest of your life kind of free tier. So java.ms/free is a really cool site to go to. I've seen a lot of talks already using VS Code. It's a really cool IDE that Microsoft put out. It's free, open source. It's developing rapidly. I highly recommend that you check it out. It's a really lightweight IDE. It pops up really quickly, and you can get your job done. With that, I'd like to say thanks. I've got 8 more minutes, so unless there's questions, I'm just going to carry on. I've got more slides that I can keep going and going. Right, I'm just going to carry on. If people have questions, feel free to come up to me afterwards. Otherwise, if you want to go out and stretch your legs, feel free to do so. So, more tips. Warning, these are overflow slides. They don't quite have the same level of quality as the slides that have just happened. First of all, I want to talk about builders and constructor telescoping. Builders are a far nicer way to have an API compared to constructor telescoping. Constructors are really important. They kind of specify the minimum set of API that's available, that provides a valid state for that class. And sometimes, though, you can end up with a constructor that has one argument, and then you think, well, as a convenience, I will provide more and more and more convenience constructors that take more and more API in. Oftentimes, though, builders are a better way to do this. So here's a kind of degenerate example, right? A pizza has to have a size. We can't have a pizza without a specified size. But let's start adding some convenience to the developer, right? Let's start adding cheese as an option, and then we'll go, well, let's just add another telescoped constructor that also takes a Boolean for pepperoni, then one for bacon, and it goes on and on and on. And this is a really ugly way to do API. The only upside to this approach is that this class can be considered to be immutable. If you set all the values in the constructor and you don't have setters, you can make all the fields final, and that's really good in concurrent systems. But in this case, we don't really care about the concurrency of our pizza class. So an alternative approach is to use setters. Obviously, as soon as you go to setters, you can no longer be immutable. Your class has to have a setter, which means that the fields can no longer be final. But the nice thing about a setter approach is that it's easy to read and it's easy to scale. If you all of a sudden come up with a new topping tomorrow, just add a setter, a getter, and a field. We could go back to our friend static factories right from the beginning, right? We can have every single permutation of a static factory that create small cheese pepperoni pizza, create medium cheese bacon pepperoni pizza. You can tell I had meat on my mind when I wrote these slides. That's not going to scale at all. There's another way we could do things that I don't cover here, and that's, well, all the toppings could be part of a topping enum. And then we could just have an enum set of all the toppings, right? I didn't cover that here, but that's probably one of the better ways to do things. What we're going to be covering is builders. So I hope all of you are familiar with builders, but here's a pizza class. It's got a private constructor that takes a builder as its argument. All the fields are final, so we've got the immutability back, and you can see when the builder's passed in, we just read the values out of the builder. So where that comment is about the builder class being here, that's what's coming up on the next slide, but just imagine it's kind of there. So when a user wants to create a new pizza, they go new builder, they specify the size and argument into the constructor because that's kind of the prerequisites. And then they've got this fluent API that they can go .add cheese, .add bacon, .build. And that's going to return back to them a pizza as specified. And that's the kind of thing that we do a lot of at Microsoft in our convenience APIs that I talked about earlier. The downside of it is that you have to have builder classes, so it kind of increases the surface area of your API. All of a sudden you have builder classes as well. So this is an example from the Azure APIs. Let's just create a new virtual machine, and it's just this fluent API, and at the end we say .create, and we end up with a virtual machine created in Azure. I've got 4 minutes. I may quickly run through support for Lambdas, right? When designing API, it's really important to consider if you want to support Lambdas, and if you do, you have to remember that you have to have an API that supports a functional interface as an argument. So who here is familiar with the Swing UI toolkit? Oh, wow. More people in Copenhagen knew Swing than here. That's interesting. So if you're familiar with Swing, the way it worked is if you had a button and you wanted to listen to people clicking on the button, for example, you'd implement the mouse listener interface. And the mouse listener interface consists of these 5 methods. And you'd implement the methods that you cared about, and you just have no ops for the rest. That's not going to be a Lambda expression. What they also had in Swing was the mouse adapter, which was basically a class that implemented the mouse listener interface, and it no-opt all of those 5 methods. That way you could only implement the method that you cared about without the additional noise and having to no-opt all the other methods. This still can't be a Lambda expression, however, because Java doesn't know which of the methods you want to be your Lambda expression. As I said, a functional interface has to have a single abstract method. In the case of a mouse adapter, there's no abstract method. When we were doing this for JavaFX, we realized that Lambdas were on the horizon and it was going to be done in this single abstract method approach. So we inverted it a little bit. Now you can see that we've got a rectangle class here, and we have far more API on the rectangle. So you can see set on mouse clicked, as opposed to add mouse listener. And now we're specifically saying that when the mouse is clicked, we pass in this event handler. And the nice thing about doing it this way is that we end up with a Lambda expression as shown at the bottom. So it's just, the point I want to make is if you're considering doing API that has Lambda expressions, just make sure that you're very conscious of functional interfaces and using them. Now, I think I'll end it there. I've got more and more and more, but what I'll do is I'll go back. And say thank you very much for your time. If you've got any questions or compliments or concerns or insults, jonathan.giles@microsoft.com. My manager's down the front here. Shout out insults later when he's left the room. And follow me on Twitter @JonathanGiles. Thank you very much.